Okie dokie, day 4. So we are going to continue moving on with our unit 3, and all that we are doing today is our average atomic mass, and then I will be making another video over how to calculate molar mass. So our average atomic mass. So on here we have our handy dandy periodic table, and you'll notice on our periodic table gives us an example of hydrogen, and it tells us that the 1 up here represents our atomic number. We have our element symbol, the element name, and then you'll notice right here it says the average atomic mass, okay? And basically what that is meaning, okay, is that is our weighted average of the masses of the isotopes of a given element. So right here in this blank, we're going to put the atomic masses given on the periodic table are weighted averages of all isotopes that exist in nature for a given element. Okay, so I wanted to basically kind of give you guys an example really fast. So I have right here, I have magnesium, and on if you're looking at your periodic table, you'll notice again we have our atomic number, our symbol. I would write out magnesium, and then I have our average atomic mass. So what this is basically saying is magnesium has, isotopes, and those given isotopes, when you have all of those, you calculate them to, which we'll do in a little bit, to basically get our average atomic mass. And then what you can do is you can figure out which isotope basically has the greatest percentage of that average atomic mass that we have. So to calculate our weighted average. Now, what I would basically, the best way for me to explain it and show you is you have your average atomic mass. And what you can do is, in parentheses, okay, so you have the mass, okay, of your first isotope, okay? You will multiply that by the fraction of that isotope, and to get that fraction, basically what you would do, because you need it in decimal, you would do your fraction, or your percentage, divided by 100. And we're obviously going to do some examples. Then, okay, you would add the mass of your second isotope with the fraction of that one, and so on and so forth, depending on how many you have, okay? And again, we're going to do a bunch of examples so that way we can kind of get in the hang of it. So our units, so our average atomic mass is given in units called atomic mass units, or AMU. So atomic mass units. Okay, so atomic mass units, or AMU. Okay, so we'll need to make sure that whenever we are boxing our answers, we would put, you can abbreviate and you can put AMU at the end, okay, because you will need to have that. So let's do this first example. So it says if two nitrogen isotopes occurred with the same abundance in nature, okay, so 50% in 14 and then 50% in 16. The average atomic mass for nitrogen would be what? So when I do this, what I'm going to do is I'm going to, on the side over here, I'm going to write out in 14. Okay, so I found that whenever what we're going to do when we're calculating this, there's kind of just 3 steps. So the first step you're going to, well, I guess there's kind of 4 steps. The first step, I would write out on the side your isotopes that you have that you're going to be calculating, okay? And then you're going to want to write out how you'd be solving this. So we have N14, okay? It says this 14 right here is telling you it is the mass of that one, okay? So what I'm going to do is I will take this 14, because that's my mass 1, okay? And then I have my percentage. So I'm not going to just put 50% because, and a great example for y'all to understand and realize is we have, just like in school, okay, our tests, okay, are worth 60%, okay, and then our quizzes are worth 40%, okay. Now let's say you have a 90 average for your tests and then you have an 80 average for your quizzes. Are we going to just add 90 and 80 and then divide by 2? Heck no, because then you would basically, be hurting your grade because your tests weigh that average, their weighted average is more than the quizzes. Okay, so all you would need to do is you would take that percentage and divide so that way you can figure that out. Okay, so what I'm going to do is I'm going to take this percentage, okay, which is 50, and I would do, to calculate that, I would just take my 50, okay, and I would divide that by 100. Same thing for here. I would take my 50 and I would divide by 100. Okay, so over here, I'm going to do 14 times 0.5 because that's what I get whenever I divide. Okay, and then this would be 14 also. Sorry, not 14. Oops, Miss Goggin made a mistake. That would be 16. Okay, that's my mass of my second one times 0.5. Okay, so whenever I plug this into my calculator, I'll be able to see 14 times 0.5, which again, you probably might not have needed to use a calculator. 7, 16 times 0.5. Okay, we get 8. So we have our average atomic mass, and the next thing that what we would do is we would add them together. Okay, that would give us 15. So our average atomic mass for nitrogen would be 15 AMU. Okay, cannot forget your units. So it tells us now to look at our periodic table. So I'm going to look on my periodic table, and it's saying what is the real atomic mass for nitrogen. So on our periodic table, I will come over here, and it's 14.01. Okay. So 14.01. This tells us that is our average one. So I can look at my two isotopes and I can see, okay, which mass was closest to our average atomic mass that we got for over here. This one, okay? So basically, that N14 would be, even though it says it's split in the middle, it would be closer to that they don't. So since it's not 15 AMU, we know that the isotopes do not occur equally in nature. So based on that, the isotope that's more common would be our N14. Okay, and we were able to see that by looking at our real atomic mass for nitrogen. Okay, so here we go. Moving on to our practice number 1. So boron has 2 naturally occurring isotopes, boron 10 with an abundance of 19.8%, and then boron 11 with this abundance of 80.2%. We're going to calculate the approximate average atomic mass of boron. So what I am going to do, and I also want you guys to keep in mind that we will be rounding. We will round to 2 decimal places. I'll write that up here. Round 2 decimal. And the reason I say that is you can notice on your periodic table, all of these are rounded to 2 decimal places. So I'm going to come out here on the side, all right, and I will write boron 10, okay, and then I will also write boron 11, okay. So boron 10, I will take my first mass, which is 10, okay, And then I'm going to come down here and I would do 19.8 divided by 100, okay? So 19.8 divided by 100 gives me 0.198. And again, you don't have to use your calculator. If you can just do the math in your head, by all means, do that. I just am going to be showing you guys with the calculator so that way you can kind of get in the habit of it. Okay, and then we have our boron 11, so our mass is 11. Okay, and then 80.2 divided by 100 is going to give us 0.802. Okay, so and I'll just write that out here so that you can see 80.2. Okay, so I will do 10 times 1.198, okay, and I get 1.98, okay, and then I will do 11 times 0.802, and I will get 8.822. Okay, so then our last step is we add the numbers from this step together. Okay, so we will add them. 1.98 plus 8.822. I will get 10.802. Okay, and like I mentioned, we will just need to round to 2 decimal places, so that will round to 10.80 AMU. Okay, and I will box my answer and show that I am done and finished that. And we would make sure that this type of work does need to be shown. Just like for dimensional analysis, we do need to be able to see that you know how to do all of it in order to get full credit. Okay, practice number 2. So neon has 3 naturally occurring isotopes: neon 20, neon 21, and neon 22. So we're going to do the same thing that we've been doing, and now just move on with neon. So we have neon 20, neon 21, and neon 22. Okay, so what I'm going to do is I'm going to take my mass of my first one, which is 20, and then I will get my percentage, which is 90.62 divided by 100. Okay, and that gives me 0.9062. Okay, and then I have my mass of my second, which is 21, and then I will multiply, or not multiply, I will do that percentage, which is 0.2700 divided by 100. It's going to be a lot smaller of a number, 0.0027. My third one, where I will take that percentage, 9.110 divided by 100, 0.0911. Okay, so I have all of my percentages converted. I will now multiply my individual ones. I get 18.124. Okay, so I then will add all of these up, and I get 20.149. And again, I only need 2 decimal places, so I will round that to 20.18 AMU. And one thing to kind of keep in mind is whenever you're looking at this, you can notice which isotope basically is more common. So on this practice one, we were able to see that with 10.80, it kind of rounded up, and our boron 11 was more common, and then here you can see the neon 20 was also. And our last practice, sulfur, it has 4. So here we go. We have sulfur 32, sulfur 33, sulfur 34, and then we have sulfur 36. Okay, so I will take my mass and I will calculate and plug in. I will do my 94.99 divided by 100, okay, and I get 0.9499. Then my sulfur 33, my mass is 33, and I will do that 0.75% divided by 100, okay, and for that one I get 0.0075, okay. Mass of 34 for sulfur 34, I will take that 4.25% and divide that by 100, okay, and I get 1.445, okay, and then, oops, did that one wrong. See, I make mistakes too, that's what happens. This is 0.0425. And then my last one, mass of 36, and that one is 0.0001. Okay, get that 100. All right, so I'm going to multiply all of these together and see what I get. 30. So I have all of my totals. I'm going to now add them all together. And I get 32.0929. But again, like I mentioned, we will round to 2 decimal places, round to 32.098. And based off of that, we can see that 32.09, this sulfur 32 is our most common isotope out of those. Hope this video was helpful, and I will see you guys back in a little bit for molar mass.